Welcome back. The next example is about composite functions. So I just wanted to remind you the definition of composite functions and the notation that we use. As you see, to define a composite function, composition of f and g, we use this little circle notation here. So when we see that, we're going to take it as like the composition of f and g, and then this is defined as a brand new function as f of g of x. The domain of the composite function is the set of all x's in the domain of g, because you see the very first entry is your g, so you first take the input x for g, so the domain is going to be the domain of g. You look at g of x becomes an input for the function f, right? So then you look at the images of g of x under f. We have two examples, in fact. In one example, we're going to find f composed by g, and in the other one, we're going to find g composed by f by using the definition of composite functions. All right, let's use the definition of f composed by g. Remember that we use this circle notation here that essentially means that you're composing two functions, f and g. And by definition, it's going to be f of g of x. It's going to be f of, what is g of x here? X squared plus 1. So in other words, we start with x. The image of that under g is x squared plus 1. So x squared minus 1. So x squared minus 1 becomes an input for f. So what does that mean? Well, whenever I see x here in the description of f, I'm going to replace it by x squared minus 1 and in here as well. Okay, so let's just do it. Well, we have one square root of x here, so I'm going to replace x by x squared minus 1. So I have square root of x squared minus 1. So the composite function, which is the composition of root x and x squared minus 1, is root x squared minus 1. Here the order is very important. As you see, f comes before g, and that's what you get. And in the second case, part B, we have g composed by f. And using the same definition of that, g comes first, so we're going to look at g of f of x. So x is the input for f, and f of x is the image of x's. So I'm looking at g of root x. I just copy that down here. So now root x becomes an input for g. Here we go. What does that mean? Well, I'm going to replace x here everywhere by square root of x. Let's just do it. So I'm going to take the square of that, quantity square of that. Let's use a parentheses here. And minus 1. And what is the square root of x quantity squared? That's just x. So this time the composition of g and f, g is the first one, spits out x minus 1. So as you see, two composite functions are totally different, and the order in between them is very crucial. In each case, we use the definition of composite function. So whichever one comes first, you write it as, like in this case, for example, f of g of x, and in this case, you write g of f of x. All right, this is the end of the video. I'll see you in another video.